This is the video for section 2.2 notes, slides 9 and 10. All right, so you're told here, it says if u of 6 equals 2, u prime of 6 equals -4, v of 6 equals -1, and v prime of 6 equals 3, find each derivative at x equals 6. So remember, u and v are two functions of x. So this is really like saying we have u of x times the function v of x. So if I want to find the derivative with respect to x of the product of these two functions, I'm going to use the product rule. So if I have u of x, we have u times the derivative of v. So that would be like dv dx plus v times the derivative of u. So that'd be du dx. Now, remember, these are like functions. So if I have u, that's really meaning like u of x times dv dx. Well, that's like saying v prime of x plus v of x times the derivative of u. That would be like u prime of x. So it's a slight difference in notation, but it makes it a little easier to understand. So now if I want d dx of uv evaluated at x equals 6, I could use this notation, d dx of uv evaluated at x equals 6. So how do we find that? Well, we're actually going to find u of 6 times v prime of 6 plus v of 6 times u prime of 6. So then I just am going to fill in the individual numbers. So if I look back up here, u of 6 is 2. So this is going to be 2 times v prime of 6. v prime of 6 is 3. 2 times 3 plus v of 6 is -1 times u prime of 6, which is -4. So I have 2 times 3, which is 6, plus -4 times -1, that's 4. So this result is 10. All right, next one. Basically the same idea, okay? But now we're using a quotient. So d dx of v divided by u. So this is going to use the quotient rule. But remember, the question here says v divided by u. The quotient rule that we wrote down gives it for u divided by v. So it's important to remember, in the quotient rule, we take the bottom, the denominator, u, times the derivative of v, so u dv dx, minus the numerator, or the top, which is v, times the derivative of the denominator, which would be du dx, all divided by the denominator, u squared. Now, remember, we want to evaluate this at x equals 6. So we're going to say the d dx of v divided by u evaluated at x equals 6 is going to be u of 6 times v prime of 6 minus v of 6 times u prime of 6, all divided by u of 6 squared. All right, so u of 6, once again, if we look up there, 2 times v prime of 6, 3, minus v of 6, -1, times u prime of 6, -4, divided by u of 6, which is 2, squared. All right, so now just a little bit of simplification here. 6 minus -4 times -1 is 4, divided by 2 squared, which is 4. So 6 minus 4 is 2/4, or 1/2. All right, and then the last one, okay, very similar, but now I want the derivative of 3v minus 5u. So we're actually going to take the derivative of them separately. So what's the derivative of 3v? Well, it's going to be 3 times the derivative of v. What's the derivative of v? Well, it's dv dx minus 5 times the derivative of u, which is du dx. It's actually really quite simple. So now, notationally here, we want d dx of 3v minus 5u evaluated at x equals 6. And so I'm going to have 3 times, remember dv dx is like v prime, so v prime of 6 minus 5 times du dx, or u prime of 6. So 3 v prime of 6, v prime of 6 is 3, minus 5 times u prime of 6 is negative 4. So 3 times 3, 9, minus 5 times negative 4, so plus 20, so 29. All right, so that's just evaluating some derivatives numerically using the product and quotient rules. All right, so that's slide number 9. And then slide number 10. Find an equation for the normal line to the graph of f at x equals negative 2. All right, so what we need to remember is if I want to find the equation of any line, I need to know a point and a slope. All right, so starting off the point. Well, remember, it's at x equals negative 2, so our point is going to be negative 2 comma f of negative 2. All right, and so then we want to evaluate this. So f of negative 2, so 5 over 1 plus negative 2 squared. So if you need to write this down, f of negative 2, 5 over 1 plus negative 2 squared. Negative 2 squared is 4. 1 plus 4 is 5. 5 over 5 is 1. So my point is at 2, 1. All right, next, slope. I want the equation of the normal line, but in order to do that, I have to find the slope of the tangent line. So the slope of the tangent at x equals negative 2 is going to be f prime of negative 2. So in order to find f prime of negative 2, the first thing that I need to do is find f prime of x. All right, so f prime of x using the quotient rule. All right, so I'm going to take the denominator, the bottom, 1 plus x squared times the derivative of the numerator. What's the derivative of 5? Remember, 5 is a constant, so its derivative is 0. Minus the numerator, which is 5, times the derivative of the denominator. So the derivative of 1 is 0, plus the derivative of x squared, which is 2x, all divided by the denominator, 1 plus x squared, quantity squared. So that's f prime of x, but we could probably simplify it. So f prime of x is, remember, 0 times anything is 0. And then I have minus 10x, all divided by 1 plus x squared, quantity squared. So that's f prime of x. So now, once again, what is the slope of the tangent? So m tan equals f prime of negative 2. So that means negative 10 times negative 2 divided by 1 plus quantity negative 2 squared, quantity squared. And so I get negative 10 times negative 2 is positive 20 divided by 1 plus negative 2 squared. Negative 2 squared is 4. 1 plus 4 is 5, and 5 squared is 25. So 20/25 or 4/5 is the slope of the tangent line. So I want the equation of the normal line. So I have to find the slope of the normal line. Remember, is the opposite reciprocal of the tangent because they are perpendicular. So negative 5/4. So now I know my point and my slope, and so I can write the equation of the normal line. So the equation of the normal line would be y minus 1 equals negative 5/4 times x minus negative 2, or x plus 2. So that is the video for slides 9 and 10.